All right, well, welcome everybody. This is the Introduction to Job Submission Scheduling and Queuing on Savio. My name is Amy Neeser and I am the Consulting and Outreach Lead and Research IT. And I wanted to just take a quick moment and tell you a little bit about Research IT and some of the things we have going on. So what we do, and many of you know this, is we provide research data and computing technologies, consulting and community to the UC Berkeley campus. And really our goal is to advance research through IT innovation. And what that means is we're really the interface between researchers, all of you, and the many options on campus. And we really advocate for your needs and your perspectives. So we're really poised at the intersection of research and technology and can help in areas like cloud computing, high performance computing, virtual machines, and data management. And one of the ways that we do that is we hold office hours every week. And I will put a link to the things I'm going to be talking about in the chat when I'm done here. But we have office hours on Wednesday afternoon and Thursday mornings where you can drop in and get help on those topics. You can also email us and set up a consultation. And we also hold events. So we have a monthly cloud meetup. We also have a security and research data working group where we work together with the D-Lab on that. So researchers who are working with sensitive data can come together and speak with each other. And we also are the main planners of the Women in Data Science Berkeley event, which is coming up in March. So a really strong focus of our program right now is really on secure research data and compute. So if you are a researcher who is working with sensitive data, we would love to hear from you because we're building services for that, virtual machines and high performance computing and storage. So please get in touch if that's the case. And the last thing I will say is that we are hiring in research IT. So the folks that do these trainings and staff these office hours, many of them are domain consultants. So if you are interested in becoming a domain consultant, I will drop some information about that in the chat as well. So with that, I will turn it over to my colleagues for the training.
Great, thanks, Amy. And some of the things that Amy mentioned are also linked to in the workshop materials. So I have you can see some of the links up here in the page that I'm sharing. If you want to have all the materials in front of you, Amy sent out a link to the materials, which are all in a GitHub repository by email, but also I put it in the chat at the tiny URL that's listed in the chat there. Okay, so there are going to be three of us presenting. I'll be presenting roughly the first third, and then my colleagues Wei Feinstein she'll do the second third, and Nicholas Chan will do the third for a full 3/3. In terms of questions, feel free to just unmute yourself and ask a question verbally. I definitely invite that. It'll make for more of an interactive experience. I've been doing a lot of teaching online this semester, and the sessions where people are asking questions are at least much more fun for me and hopefully for others. But also feel free to just post questions in the chat, and we have several of us, including the other presenters who are not presenting at any given moment, can answer questions in the chat as well. Okay, so basically all the material is in the that slurm.md file that's in the repository, and that generates the two HTML files that are in the repository. So one of them, the slurm_slides.html, is basically the slides that we'll present, and the other is basically the slurm.html file. Is just a single file that has all of the content rendered as an HTML file, but just basically as a single page. So that's just a little bit of orientation for where what materials we'll cover and what format they are in. Okay, and then I guess we covered this and we covered that. Okay, so the basic idea here is that we want to talk in some detail, in more detail than we would cover in some of our introductory trainings, which some of you may have attended, about how you actually submit jobs and how you diagnose when things are going correctly or incorrectly with the jobs that you've submitted. And so a lot of the questions that come into us with problems are, I submitted my job and it's not running, or it's not running yet, or how do I get it to run? How do I get it to start more quickly? Or can you help me figure out, what's wrong with it? So the idea behind this training was to really cover a number of those topics. So I'll start out by talking in some detail about submitting jobs, and the different kinds of jobs you can submit and the different syntax you would use to submit those different kinds of jobs. And then Wei will talk about how our scheduling software actually really works behind the scenes in terms of how it's configured and how it sort of manages allocation of the computing resources to these different jobs. And then Nicholas will handle basically sort of the trying to diagnose situations where your job is either not running properly or more likely just not going to run at all. And so he's been working in particular on a very nice script that is basically sort of a magic script that tries to diagnose what could possibly be going wrong with your submission and help you out with that. So he's going to do a demo of that and make some more comments around that general topic. Okay, so I will start out with just sort of setting the stage a little bit. I think most of you know this, but Savio is of course a Linux cluster or high performance computing cluster. And what that really means is it's basically a set of a whole bunch of workstations all networked together. And so by virtue of being that sort of setup, there are both login nodes and compute nodes, and there needs to be software that basically sort of manages the fact that all, hundreds and thousands of people, hundreds and thousands, not hundreds of thousands of people are all going to be submitting jobs and competing for the different compute nodes that are available to do your computations. So of course you log into when you log in, you're put on one of the login nodes. And you can access your files from any of the login nodes or the compute nodes. And then this point number 3 is that all of your computations get run not on the login nodes, but on the compute nodes. And these computations might be, and often are, jobs that are parallelized to run across many CPUs and potentially across many new CPUs on many nodes. You can also run serial jobs that use a single CPU, although there's an important note there, which is most of the machines that we have are allocated on a per node basis. So you will be basically charged for the entire node, even if you only use a single CPU. Okay, so this is sort of a schematic of what the cluster looks like. And I won't sort of cover all of this because this is from our intro training, and which also discusses basically dealing with data transfer onto Savio, and also talks about where your files are stored on Savio. But the main thing to point out from this diagram is you're the user up here in the top left, and you're generally going to use SSH in one form or another to basically connect to one of the login nodes, which are sort of in the sort of middle upper left here, noted LN000 up through LN003. Now, once you're on those login nodes, you can, of course, copy files and look around and things like that. But the only way that you're supposed to be doing any real computation is to submit a job to our scheduling software. And the two main submission commands that you would use are sort of written vertically here, are sbatch and srun. And so what those do are they basically, on your behalf, they make a request to the scheduler, which is called Slurm. And they say to the scheduler, hey, I need, let's say, 2 nodes for an hour. And I need to have those nodes be on the Savio 2 partition, because that's the particular hardware I want to run. So the scheduler is managing your request as well as your friend's request and your not so good friend's request and all the other people you don't know, all of whom are submitting jobs around the same time. And the scheduler is trying to figure out which job should I run first, which job do I run second, how do I queue these jobs if there are jobs that have to wait until resources become available, and so on and so forth. So the scheduler is basically sitting between you on the login node and your job running on these compute nodes, which are these sort of cylinders down here in the lower portion. Okay, so any questions at this point? Okay, so I've said most of this here about what the job of Slurm is and why we have to run a scheduler on the cluster. So a few sort of the bullet points here are basically that Slurm is basically trying to take each of your jobs and allocate access to the compute resources we have. And it's going to be starting your jobs and then monitoring those running jobs as they run. And it's going to be managing the queue of jobs that are pending, because in many cases, basically all of the nodes are going to be busy, and your and other jobs will be sitting in a queue, a prioritized queue waiting to start. So I do want to point out, actually, we just sort of in conjunction with setting up this training, we did update a whole bunch of our documentation around using Slurm to try and provide more information, and in particular, more information in terms of troubleshooting. So on our website, under the Running Your Jobs section, which many of you will probably have seen before, we did sort of reorganize that content there. And so the Running Your Jobs page here links out to 4 new pages that try and lay out in more detail sort of the key parts of submitting and monitoring and checking your jobs. From determining what resources your jobs can use, to submitting them, to understanding when your job will start, and then monitoring jobs that are already running. So do feel free to take a look at that, noting that some of that content is new. And basically most of what we're going to say here is mirrored in that updated documentation. Okay, so a couple of the main things that when you're submitting a job that you need to specify to the scheduler is you need to tell it basically what account you're going to be using. So this will generally be either a condo or an FCA. And you need to specify the partition, which is basically what kind of hardware would you like to run on. So there are different generations of hardware, from sort of slower machines that were purchased a number of years ago to faster machines that were purchased more recently, as well as different kinds of hardware. There are some machines that, of course, they have GPUs, some machines that have more memory than others, and some machines that are particularly set up so that you can run serial jobs or jobs that only need to use a small number of cores. And those are called the HTC nodes. So if you do want to see what accounts and types of nodes, partitions, you have access to, you can basically run this command here and then inject your username here at the end. And what this will show is, for my account, this shows that I have access to 2 different kinds of accounts. I have access to a condo account in the statistics department, which is where I'm located. So that's the CO stat that I see here. And I also have access to a faculty computing allowance because I have a faculty position. And so many of you will have access, well, essentially all of you will have access either to a condo or to a faculty computing allowance, either your own if you're a faculty member, or the account, the FCA of the faculty member that you're working with. And in some cases, you may have access to both, and you may be able to switch back and forth and choose one or the other depending on what you're trying to do. So a couple things to note about this is, if we look at all of the lines that say FC that are for the faculty compute allowance, you have access to basically to all of these at regular priority. And that is, and you can sort of see that that's the case because for all of these, you'll see there's a Savio _ normal, and this is under the QoS column, which is a little bit hard to show here because I didn't print it out in a particularly user-friendly way. But if you see Savio _ normal on any of these lines, that indicates you have regular priority access. And that's going to generally be true for most of the partitions if you're using a faculty computing allowance. Now, the situation is quite different if you are running under a condo, because the only nodes that you have highest priority access to are the kinds of nodes that the PI or PIs of the condo purchased. And so in this case, I'm part of this statistics department condo, and the statistics department purchased some nodes in the Savio 2 GPU partition. So you can see here that over here, sort of on the middle right, there's this stat GPU 2 normal, and that indicates we have normal or sort of regular high priority access to nodes, these GPU nodes. And we also purchased some Savio 2 nodes. So you can see here in this line that we also have this stats Savio 2 _ normal. So again, that indicates sort of regular or highest priority access to nodes there. But for all of the other rows here that are not Savio 2 GPU or Savio 2, you'll notice that all of them just say Savio _ low prio, which stands for low priority. And what that means is we only, as part of the condo, I only have access to nodes, for example, in the Savio 2 HTC partition. Oops. At low priority access. And that's because we in the statistics department did not purchase any of those Savio 2 HTC nodes. And so we're basically at the bottom of the barrel in terms of our access to those relative to condo owners who purchased such nodes and relative to the faculty computing allowance users. Okay, so let me pause. I could take a little drink and see if there are any questions at this point. So let me just do a fairly quick example of actually running a job. And the main purpose of this will be to see how we can actually monitor running jobs. So this here is a basic job submission script. And in the comments are basically, the comment followed by a capital S batch are basically the flags that tell Slurm what are the sort of parameters of your submission that you want it to run under. So this is saying I'm going to set up the name of the job is test. That is not required, but it can sometimes be handy. You are required to say what the account is. So I'm going to submit this to the condo that I was mentioning before. And I want to submit to the Savio 2 partition. And then you also have to set a time limit. And this is just a 45-second time limit because this is a quick job. And then this particular job is just that I'm going to run some code in the file calc.py. Okay, so let me switch over here to an actual window in Savio. So I'm on the login node, which you can tell because it says Pechoric at ln003. And I'm in a directory that contains all of the files from the repository for this training. And if we look at this job.sh, that looks precisely like what I just showed you a moment ago. And if I look at this calc.py, we'll see that all it does is basically just does a whole bunch of sort of computationally intensive linear algebra. So what it does is not particularly important. I just needed a job that would run for a little while, and that in this case, because of the way we have Python set up, it's actually set up to use multiple cores because the linear algebra in Python on Savio is threaded. Okay, so let's go ahead and submit this job. Actually, first I'm just going to see if there are free nodes on Savio 2. So I can do sinfo -p Savio 2. And this shows me that there are at the moment 5 idle nodes on Savio 2. So I will probably be able to start my job right away because I'm only requesting one node for a very short period of time. And Wei will sort of get into this sort of issue a little bit later in the training. So I'm going to do sbatch job.sh. That spits out a number, which is the job ID. And so I can do things like sq -j 7143201 and see that that job is pending. So it says it's pending because of the group node limit. Oh, right. Okay. So I'm just remembering I actually submitted some other jobs to the condo earlier this morning. So let's go in and actually change that. So let me actually cancel that job because it's not going to run while those other jobs are running. So I'm going to change this to now run under, well, my faculty computing allowance is actually expired. So I'm going to use a different account, which is an account because I work on Savio. So you would not be able to use this account, but I think this should now work. So let's try that again. Oops. Okay, I didn't mean to cancel it. I meant to look at the queue. So I restarted it, and now let's try this again. Okay, so that did not work either. So let me see what's going on here. So another thing that we can do is if we do ls, we can look and see what the output was from the submission. Oh, I see. I got the job ID wrong. So I should have been saying sq -j03. And now at this point, the job may have just finished. Okay, I'm going to start it up again. Sorry for all the back and forth, although this is actually somewhat useful to sort of see these things that can go wrong live. Okay, so this is now number 5. And this is now running. So let's go ahead and we can actually sort of see as it's running some information about how much of the resource it's using. So this says it's using 4% of the CPU. And that's 4% of the total collective CPUs across the node. So this is basically saying it's using 1 out of the 24 cores. So it's not fully parallelizing and using all the cores. It's basically only using the equivalent of 1 core. And it also shows that it's using about 3 gigs of memory on the node. So this is in megabytes. So this is about 3.3 out of the 64 gigabytes of memory that the job could use. Okay, so let's see if that thing is still running. Okay, so now it's finished. I'm actually going to run it one more time. And the other thing that we can do to actually get onto the node and see what's happening as it's running is we can do this -- job ID. And then say I want to run a bash session. And so you'll notice the prompt has changed to this node 104, which is the node where the job is running. And now we can see that this is the running job. Okay, so it's about to abort, and it just sort of flashed up briefly. But as it was running, it sort of flashed and you didn't really see it, but it actually showed that it was using 2,300% of CPU, which means it was actually using about almost all of the cores. So you can run a command like top once you're on the node, and you could actually see the CPU usage and the memory usage of the job and the different processes that the job may have started as they're running. Now, eventually, because the job finished, it just kicked me out, and then now I'm back on the login node here. I also seem to have lost my flashing cursor for some reason. Okay, so any questions or comments there? Okay, so the kind of monitoring that I was just showing in terms of using that wwall command and actually connecting directly to the node and then running top, or you could run ps or various other commands to sort of monitor the status of the node. You could run free to look at how much memory is being used, for example. All of that is if your job is running, seems to be, is running, and you want to see, does it seem like it's behaving the way that I would expect? What Nicholas is going to cover at the end is when your job won't even start and it's just pending, and he's going to try and help you diagnose cases like that where your job actually is not actually starting. But the commands that I just showed are quite useful for the case where your job does start, and then you want to get a sense of, is it running the way that I would expect? And most often the question that people will have is, how much memory is it using? And is it actually parallelizing and using multiple cores? Okay, so let's go back to the slides here. So we covered this. One thing I didn't say, there's a nice command called saccount that you can run after your job has finished. And there are a whole bunch of different columns that you can ask it to print out. That's what's after the -- format here. And this will give you a whole bunch of information about, it would probably work to run it. It might work to run it as it's running. It might show you some information, but most often it's run once your job is completed, and you could go in and look, for example, like how many nodes did it run on, how much memory did it use, did it exit with a cancellation code, or did it exit successfully, and so on and so forth. So we could actually do that. Maybe it's worth the time to do that here. I could run that here, and this is going to be tricky if I don't have my cursor. Let's see. Okay, so I can type in the number of my job, which was 3206. And you'll see this just prints out a little bit of information that suggests it used at a maximum. This is in kilobytes, so at maximum used about 3 gigabytes, and it ran for 22 seconds. And you could change, you could change these flags to get a lot more information. If you do man of saccount, it will show you a whole bunch of, it'll show you sort of all the different options you can give to the -- format flag. I'm not quite sure why that took quite so long. But sort of all this information you could sort of page through here and see what flags you could use. Okay, questions or comments? Okay, so let me say a little bit about parallel job submission, and then I'll fairly briefly go over a few different other kinds of job submission that you could do. So the main sort of flags that you need to tell Slurm when you're submitting a job where you want to use more than one CPU are, you could ask it for a certain number of nodes, you could ask it for a certain number of tasks per node, and this is generally going to correspond to the number of processes you want to run on each of the nodes. And you can ask for a certain number of CPUs per task, which could correspond to the number of processes you want to run, or it could correspond to the number of threads that you want to run if you're running some threaded code like OpenMP code. And the other thing you could do is you could ask just for a total number of tasks as opposed to asking for the number of nodes and then the number of tasks per node. So you can sort of mix and match these things in order to get the right arithmetic of sort of the right number of CPUs accessible to you on the correct number of nodes. So if you were using MPI, which generally is used for parallelizing over multiple nodes, one way of setting up an MPI job would be to ask for the total number of tasks, which will then correspond to the number of MPI tasks, for those of you familiar with how MPI works. And Slurm will automatically realize when it sees this that on Savio, and in particular if you're using the Savio partition, which has 20 cores per node, it would realize, oh, 40 tasks means I need to allocate 2 nodes with 20 tasks per node. So Slurm will sort of do that arithmetic for you. And in this case, then all you need to do is say MPI run and the name of your executable. You don't need to say how many MPI tasks you want to use, because MPI is basically going to interact with Slurm to figure that out and just do that automatically on your behalf. So this would be sort of a standard MPI job where you say how many MPI tasks you want to use, and then Slurm will figure out how many nodes that corresponds to. Now, in general, it's probably it may make most sense to request a number of tasks where that is the total number of cores on each node times the number of nodes that you might need. So it wouldn't really make sense to request, say, 42 tasks on Savio, the Savio partition, because then you'd get 20 on one, 20 on another, and you'd get another 2 on a third node, and you wouldn't be fully using that third node. Okay, so another comment is when you submit a job, your code in your code that runs runs in terms of the actual code of the job can make use of these environment variables that are going to be set by Slurm when it starts your job. And so you can basically make use of these to control the parallelization in your code. So you could make use of the number of CPUs that are available on the node. You can make use of the number of tasks that you requested. You can make use of the number of nodes that you requested. In some cases, you may need to actually make use of the sort of a character string that lists the actual names of the nodes that were allocated for your job. So those are all just Linux environment variables that you can make use of. Okay, so a little bit more about different kinds of parallel jobs. So some of the different flavors of parallelization you might use are you might have one node and many CPUs. And so this would commonly be the case for threaded code like OpenMP code, or if you're using threading for linear algebra in a language like Python or R or MATLAB. You can also use, this might also be the situation if you were running things like Python or R or GNU parallel to run code in parallel. Now, I mentioned a moment ago that MPI is a protocol that is often used for running code across many nodes. So if you want to run across many CPUs with more than one node, then you would be in that situation with MPI jobs. You can also run across multiple nodes with multiple cores if you're using Python or R or MATLAB in parallel, or if you're using GNU parallel to parallelize a whole bunch of independent tasks. And then what some people call hybrid jobs would be where you're using MPI to run MPI tasks across multiple nodes, but each one of those MPI tasks could, for example, also be threaded itself. And so that would be an example of what would be called hybrid job, where you're using C CPUs for each of your tasks. And so just to show this in a little bit of detail, if you were running threaded code, you would often be doing something like this. So you'd say one task per node, but then more than one CPU per task. Now, one caution here is if you actually ran this, you would only be using 4 cores on the node, and the nodes are generally going to have 20 or 24 or 32 cores. So you wouldn't fully be using all the cores on the node. Okay, you might run code that starts multiple processes to do parallelization, and this would be common in Python or R or MATLAB. And so in that case, what you might do is you might say, I want one node and then 20 tasks per node. And so that would basically set you up to be using 20 cores to say start up 20 parallel processes. So that would also be another common paradigm. And you could have instead here done minus CPUs per task if you want to. It wouldn't have any different effect. It's just that people often think of CPUs per task as being for threaded.
Today, the biggest financial commitments.
Okay, so any questions there?
I have a question. I'm not sure I'm understanding the difference between a task and a CPU.
Yeah, it's a little bit confusing because the word task is sort of an overloaded term. So I think the reason that Slurm uses the word task is because Slurm works quite tightly with MPI, and MPI uses the idea of the term task to basically refer to each of the different processes that will be run by MPI. For the most part, you can think of a task as being that one task will often just be using one core on the machine. And so if you want to use, say, 20 cores for parallelization for 20 processes, you could say minus n tasks per node equals 20 and one node. Or you could say minus n tasks equals 20 and also say one node.
Okay. Good.
Other questions? Okay, and then if you wanted to run multi-node jobs, then you could specify the number of nodes and the number of tasks per node, or as I said before, you could specify just the number of tasks and let Slurm work things out for you. One caution that I'll make here is that if you just specify n tasks, it's possible, and it will depend on sort of what partition you're on, exactly how this would work out. It's possible that you'll end up with those tasks spread, or those processes spread across multiple nodes, which might not actually work in terms of the code that you've set up. So if you want to make sure that you have all of your cores on a single node, then you need to make sure you either set nodes equals 1, or that if you use CPUs per task, that will basically force the CPUs to all be on the same node. Okay, so then just to sort of close out, here's an example of running GPU jobs. And in this case, you need to say that you want access to one GPU, as is indicated here. You always need to ask for you need to ask for 2 CPUs for per GPU. And if not, you'll get an error message back. So that's indicated, that syntax is indicated here. If you want to run a low priority job, you need to set the QoS to be the Savio low priority, although I guess this would probably work by default if you're submitting from a condo and submitting to a partition that you only have low priority access to. So this would, for example, allow you to burst beyond your condo and use many, many nodes at once. The only danger is that these jobs are subject to preemption if someone else's job needs to run code. And so if the cluster is busy, you might find that your jobs are preempted quite frequently. You can run jobs where you are requesting cores on an individual basis, and these would be jobs that generally you would run in the Savio 2 HTC partition. So here I'm requesting to use 4 cores, and I would be only charged for 4 cores as opposed to the entire node, because the Savio 2 HTC partition is allocated and charged on a per core basis, which is unusual for Savio. And the other thing about the HTC partition is it's the one partition where if you're running under an FCA, you can run for longer than 3 days. And so you can run up to 10 days using 4 or fewer cores. And for that, you need to specify the Savio long QoS. Okay, so then a couple other comments here. If you basically have a whole bunch of independent jobs, but each one is only going to use one or a small number of cores and not be able to take advantage of all of the cores on a node, there are a number of ways that you can sort of parallelize that to run many independent computational tasks within a single job. And so we have some documentation on using GNU Parallel to do that. And this is also commonly done from within tools in R, Python, or MATLAB that are listed here. And we have some documentation about these as well. And finally, I'll just close by just commenting about a few sort of common errors that occur where you immediately get back an error message when you submit your job. So one of these is if you specify a Q or QoS with the -Q that you do not have access to given the account and the partition that you've specified. And so here, for example, I'm asking to run under the normal priority in Savio 3 under this condo, and I don't actually have access to Savio 3 in general, and I certainly don't have access to it at normal priority. So it says, oh, there's an invalid QoS specification. So this would be a point where you might want to use that saccount manager command that I gave earlier to see what is the combination of accounts, partitions, and QoSs that you have access to. The second one is just a reminder that you need to request 2 CPUs for every GPU. And if you don't do that, you'll get a message about an invalid generic resource specification. And then the other thing that can come up is if you have a faculty computing allowance that has run out of service units or it hasn't been renewed in June of the given year, you may get a message that says there are not enough service units. And if you want to check the availability, check the usage of your computing allowance, you can run this command here. And this shows that basically I haven't run anything and my allocation is 0 SUs, which in this case is an indication that I never actually renewed my FCA. Okay, so that's what I have to present. Let me see if there are any questions or comments before I turn it over to Wei. Okay, Wei, do you want to take it away?
Chris, do you need to stop sharing?
Probably. Hold on. I lost track of where my,
Your window is.
yeah, exactly. That is the
All right.
problem. Okay, I think you
Let
should.
me find mine. Easier. Oh, do you see my?
Yep, we can see it.
All right, cool. All right, let me figure out fix my screen a little bit. You see my terminal?
Yes,
Okay.
although it's a little bit small.
A little small. It's a little better.
Yeah, I think so.
All right. Okay, so I'm going to start. Thank you, Chris. So Chris gave you us, quite a bit introduction on how to use the Slurm, how to submit jobs within the Slurm system, and some global variables, all that interesting stuff. So there's a lot of details about Slurm, and sometimes user complain why my job's not running, why my colleague stops running. So there are a lot of questions. That's why we want to look into a little bit deeper to see how Slurm works. So here is a Slurm overview. Slurm is an open source, really resilient, fault tolerant, highly scalable cluster management tool. So this tool basically is used to manage the job submission, to check the resources on the cluster. And this is widely used, regardless whether the cluster is big or large or small. And I think, over 99% of the superclusters around the world are using Slurm. Also, there are several other tools to manage supercluster resources. PBS is one of those, and IBM LSF is one of them. But Slurm, there's no doubt, is the most popular job management tool for supercomputer clusters. So for Savio, we're using Slurm, and by now you know that you've been using Slurm commands all along. So the Slurm will give you will give users access to resources on Savio. We have different partitions on Savio, whether it's a GPU or the CPU compute nodes, different partitions, and also different users have different projects. Whether it's a PFC account or the Conto accounts. So the Savio the Slurm will manage all of those aspects. Slurm manages the queue of pending jobs based on assigning priority to jobs. And I will talk about this in later slides. This is one of the really interesting topics or questions that the user always, want to ask about, why my job's not running. It also optimizes how the jobs with the different resources requirement can be accommodated on a cluster. And on Savio, we have so many different hardwares, right? Whether it's a GPU node, CPU nodes, or the CPU nodes with different number of cores, or whether the certain partitions can be partitioned, the nodes in the certain partition are assigned exclusively. That means when you request the node, the entire node will belong to you, or whether the certain nodes will be assigned to you based on core, right? So all those different flavors, different varieties, that is all this aspects are managed by Slurm scheduler, which is pretty amazing. All right, so here is an overview of Slurm architecture. So if you look at so basically there are three components for Slurm. The first one, the major one, is a Slurm control D. This is a controller daemon. And for a lot of computer centers, they actually have a backup. But for Savio, we only have one. Never really had a problem, so it works fine. But there's just one Slurm control D. And the other yellow box is a Slurm DBD. And this daemon controls Slurm database. So directly talking to the Slurm database. And these two daemons are not visible to users. So only us as system administrators have access to those. And the other several boxes in green is a Slurm D. So those are the Slurm daemon running on every one of those compute nodes you use. And these daemons basically monitor each individual compute nodes and then talk to the Slurm control D. Slurm control D talks to all the Slurm daemons on the compute nodes, as well as the Slurm data daemon. All right, so that's the three daemons under the Slurm software package. On the left side, look at those purple boxes. So those are the commands that some of those, I guess, you've been used in the past. As control normally is for us, system administrators, you do not really use that command, but you can always use as info to find out the cluster information, certain partition, which nodes are up, which nodes are down, which nodes are allocated. So as info is one command you can use often. SQ is, when you submit a job, or you want to check your job status, and that's SQ. As cancel is when you want to cancel a job. As the account, this one has a lot of fun features. You can check your previous jobs, you can check your job status, more detailed information about your jobs. S1 is another command to submit the jobs interactively. All right, so this is just kind of an overview of Slurm architecture. All right, a little bit deeper look at Slurm database daemon, Slurm DBD. So this Slurm has a MySQL database. All the user information, account information, your job information is stored in this MySQL database. And this daemon is basically talking to this MySQL database. So Slurm DBD tracks all the user information, account information, which account you have, which project you have, your user ID, all that stuff. Track all the job information of every user. This is a lot of information there. I'm sure, users, the top users, you must have a lot of information stored in the database. Track all the configuration information for Slurm. Yes, whether the partition, whether it's the QoS, quality of service, or all the transactions, all the information will be stored here, are stored here. Commands that used to kind of query the Slurm DBD is as account manager. And I'm sure you've used this in the past to check your Slurm account association to see which QoS, which partition, or you have to put together in order to request to submit your jobs. Okay, Slurm D. Slurm is a node management daemon. And this daemon sits on every one of those compute nodes, Savio 2, 3, 4, GPU, every one of those. Otherwise, there's no way for Slurm to figure out which node is available, what resources on those nodes. So this Slurm D runs on compute nodes and take care of, track the state of those nodes, whether it's up, down, or idle, or being allocated. There are jobs running. So all this information is Slurm-D, is under Slurm-D's territory. Also track resources available on node. Yes, whether it's how many cores, how much RAM is there, whether it's a GPU node, CPU node. So Slurm-D will take care of that. Track job running on the node, of course, right? So we'll see whether there's a job running on the node or whether it's one user or multiple users, this information. Also, Slurm-D is doing the task of launching and killing jobs. Whenever the Slurm control D says, okay, this Savio node 1 needs to go on to this job, and then Slurm-D will take over to launch the job to this node. Once the job is finished, we'll terminate the job on this node. Slurm control D. This is the brain of a Slurm. So the control daemon running on a service node. So it's only for us to manage the cluster. So Slurm control D communicates with Slurm DVD for account information, and also communicate with Slurm D to get the node state. So, so basically, it's going to find out available resources, state of the nodes for all those compute nodes under Savio, and what jobs should be scheduled to run on which node. And so the Slurm control D just manage it all, put all that information into consideration, and then figure out which job goes down which node, and also semi-reserve that node for a certain job. Slurm control D also reads configuration information so that, for example, the slurm.conf, the GPU G resource, gras.conf, and some other, all the configuration information will be read by the Slurm control D. Also, Slurm has a lot of plugins that are available there, hundreds of them. Those plugins are dynamically linked to the Slurm when the Slurm is running. And there are plugins for example, the user authentication, the task scheduling, those are all individual plugins. And for Savio, we have extra plugins that were written here in-house. For example, the one is a Spank private temp sham. Yeah, so that's the one that we configure the local and the temp directory when you submit a job. So that's our own plugin. Another one is job submit collect script. And that one basically where we are collecting users' job submission script on the fly. So all your job submission script are being collected, putting on our master node. And the other one, newly, the latest member is the Spank Slurm thanking. So this one basically, when you submit the job, we're going to see whether when you request 10 nodes, whether you still have your allowance will still be available to let you get those 10 nodes. So that's kind of pre-checking if there's, for example, your account has only 100 CPUs left, and you're requesting 1,000 CPUs, SUs, then your job will not get run. So those are plugins, and also Slurm use Munch to do the authentication. So all the compute nodes have the same Munch key installed. So that's for the communication with Slurm-D with for all those nodes communicate with Slurm. Some of the commands that I can use is as account, as queue, as info, as batch. I'm sure you've been using some of those in the past already. All right, so you might be curious, what happens when you submit a job? What are the processes? So, okay, so the way you submit the job is you use SBatch to submit the job. Basically, that's the typical way to submit the job. Srun is to request interactive note. So you can just basically watching what you're doing. Salloc is similar to Srun. However, you are not automatically landed on that node. So once you submit the job, the Slurm will check your job submission parameters, right? Whether you have the right project ID, whether you have a right account ID, that that information is being validated first. And then okay, we'll run the prologue. Prologue is a script that is embedded in the Slurm. So that basically is to set up environmental variables such as temp directory for your job to run down the road. And also we'll check, we'll request resources, check the resources being requested. The once Slurm control D talks to Slurm D, talks to Slurm DBD, and it will say, okay, whether there's enough resources for your job to run. Once you say, okay, now you have there's plenty of resource for your job to run, and then the job batches to those nodes. And by that time, the Slurm D will take over, right, to launch your job and then eventually will kill the job once it's completed. Then the epilogue script is another piece of script to clean up a node, to clean up the process on each individual compute nodes. So this is kind of a rough process, what happens when you submit the job. All right, so now we're getting into the prioritization of your job. So how does your job being prioritized? What are the factors to determine, where to put your job in a queue, right? There are so many jobs waiting. And in the Savio, you can see the plugin defines Slurm's behavior, and in this slurm.conf file, we have the priority multi-factor set up in that file, which means we have several parameters, several factors to determine your job priority. The first one is QoS, is the quality of service. So this is to set priority, this is to set the priority to different kind of projects. Condo for Savio, we really give the highest priority to condo users. So condo users, also condo project, have a QoS of 1 million. Yes, 1 million. And then for debugging queue, we'll give the QoS as a 10,000. And it goes down is the normal. When you submit a job using Savio normal, that QoS basically is a 1,000. And for the low priority, for those people who use SUs without it being charged, those low priority has a QoS 0. So you can see that based on which QoS you use, the priority is being set right there at the QoS level. The next one's a fair share. Fair share is a combination of usage and the raw share. I'll talk about that later on, but this is another big factor. The next one is job usage, job age. This one is one of the factors too. The longer you wait in the queue, the higher priority you have. Right, you wait for 7 days, you wait for 1 day, that person who's waiting for 7 days, that person's priority will be bumped up. Partition. Partition, we do not have all the partitions on Savios have the same priority score, so it really doesn't matter. And the final priority will be the sum of fair share, QoS, and age of your job. As prior, this is a command that we can get some information about a priority. One command is as prior. -W. This actually just give you it shows our configuration of which parameters which factors are considered for the priority setup. And you can see here we have age, we have fair share, and the QoS. So those are the 3 factors being considered for job priority. Now, if you go down, just look at as prior, just that command only. So basically, this is going to show you all the pending jobs. What's their priority being set up? Now we can, oh, I'm doing that wrong, on the wrong window. All right, so here, I just want to clear as prior. All right, so those are all the jobs, but currently waiting. I'm going to do the head, looking at the first 20. All right, so if you look at this portion, so this is the top 20 waiting jobs in the queue, and their fair share, and their QoS, and their age, and this is the priority. So this is how you can find out basically, you know, what's my priority of my current waiting job. So if you're interested, if you're anxious to get your job running, you can check on this. But you know, yeah, just some information. All right. So next factor to determine the priority of a job is QoS, quality of service. So for this, we have, you know, there are so many different ways to set up QoS. And on Savio, we set up, for example, max node counts, for example, for certain partition or certain project, counter project, and we can set up the maximum node counts that the user can use for each job, and the maximum CPU, and the maximum user submission. For certain, we can set up, for example, for each user, you can only submit 10 jobs each time, or you know, things like that. And the maximum wall time, typical our wall time is 72 hours. But for counter project, it really depends on the PI. We can set up, you know, like a week long, or you know. For debugging queue, actually the time is only 30 minutes. And the scheduling priority, preemption, all that. So can be set up at the QoS level. And if you look at the command here, so I'm using as account manager, show QoS, and I'm giving the format, right? Just to show, give me those fields. And you can see it's showing here. This list is really long. I just, you know, kind of give you a little, the top several lines of the, you know, lines of along. And here it's pretty interesting. You can see Savio debug. So basically, it's, you know, we defined it as when you request the debug queue, you can only get up to 4 nodes, and the time is 30 minutes. Okay, and this is the QoS, right? That's the score.
Hey, Wei.
Yes.
I just want to be cognizant of time here. Do you think you'll be able to wrap up in about 5 minutes so we have enough time for Nicholas?
Yep. Okay. All right. Okay. So I move along. Savio normal, Savio debug, and the condo will be set up as you know, the similar pattern. Fair share on Savio. So fair share now is really depends on we're looking at the group level. So you have a condo account. We're looking at all your users in the same group. In the same group, they compare the user in the same group, that how to assign a fair share to a job, basically. So for the fair share, there are 2 components: usage and share. So the usage is for a certain user, if you use them, if you submit the jobs many times in the past 14 days, that usage level will go up. For the share, basically, it's the same. We give 0.1 as the common score. I'm not going to spend much time here, but you can try the commands on this page. So it's a fair share. Basically, it's based on how much have you used in the past 14 days. If you use a lot, your fair share will go down. And here is the Savio partitions. We have so many different partitions on Savio, Big Mem, Savio 2, Savio 2 HTC, GPU partitions, and you can get that quite easily using slurm.com. Backfill.
Hey, Wei, can I just make a comment about the fair share, which I think it's important for folks to realize that the usage amount that's critical is the usage collectively of you and the other people in your FCA.
Thank you. Yes, yes. So there are several members in the same group. So all those members, their usage will be collectively considered. Yes. Backfill. Backfill is, Slurm is designed to perform a quick and a simple scheduling attempt at very frequent intervals. For example, the beginning of the job submission, when the job complete, and at the configuration stage, right? So whenever there's, for example, here on the graph, I have two jobs running, job A and job B, and job C is waiting because job C is too big. Then we have a window here. So the window 1 and the window 2. So the x-axis is the time, and the y-axis is the nodes. So those two windows available, whenever you have a small job that can fit into these two windows, your job will get run. This is called backfill. So when you try to do use the backfill, make sure you have your wall time set up short enough or the node count small enough so that it can fit into those windows.
Hey, Wei, can I ask a clarifying question about that?
Yes.
My understanding was that the gray box, that sort of fitting in would be the gray boxes on the left-hand part of the graph. So how do the gray boxes on the right-hand part of the graph relate to the gray boxes on the left-hand part of the graph?
They're kind of similar because the y-axis is just nodes, right? So, okay, so here we have A and a B. All the gray boxes are the empty spots. Actually, yeah, I just did a little bit slide. Okay, this window actually needs to be smaller. The window 1 needs to be subtract, right? Subtract the job B. Need to be a little bit smaller. The basic point is whenever is available there, those window 1 or window 2, and your future job needs to fit into those small boxes. Whether it's the time limit, make it shorter, or the node counts, make it smaller enough to fit into those boxes. To answer your question?
Yeah, thanks.
Yeah. All right, so priority and the queuing on Savio. 2 more minutes, I'll be done on Savio. So on Savio, condo users are really, we really emphasize, try to put high priority on for Savio condo users. So, but when you think about the condo users, you have to think about this aggregated effect. You have several users in the same group, and all the several users, for example, the condo has 20 nodes, and different users have combined used over 20 nodes. When next job's coming in, there's no nodes available for this group. So additional jobs will be queued until the usage drops below the limit. And that's what that means. And the pending jobs will be ordered based on the Slurm fair share priority. Basically, it's, if you use a lot, you're gonna wait longer time. Yep, so you can read the rest. So basically is, and also sometimes when condo users say, okay, I cannot, there are still idle nodes, but how come we cannot get into our job cannot be running? And sometimes it's because the partitions are full, right? And then those FCA account users' job need to finish before the condo jobs can get into. And typically, when the condo jobs are waiting, the typical window for waiting time is not that long. And we have statistics, basically, it varies, but not typically it's not long. And another priority group is the FCA jobs. FCA jobs, and also I didn't mention here is the recharge account. Those two, FCA and recharge account, basically they're the same level. Their job priority is based on the fair share. All right, so now I'm going to let Nicholas take over to talk about, to answer some common questions about why my jobs are not running. How soon do I expect my jobs to start running next? So here, Nicholas, take over.
Thank you, Wei. Can you stop sharing screen?
Yeah.
All right. Can everyone see the screen?
Yeah, looks good.
Okay, great. Hi, yeah, thank you, Wei, for that overview of how Slurm works internally. So now I'm going to go over some more practical questions about like what specifically can I do to figure out why my job isn't running. Also, when is my job expected to start? So if the job is in the queue, but you're wondering how long it's going to take. And also some tips and tricks to make your job start sooner if it seems to be taking a while. So when you ask the question, why isn't my job running yet? It could be for various reasons. So there are some reasons that are just inherent to how Slurm works. So this would be like, it's waiting for higher priority jobs. All the resources are already taken up. There's no space to fit your job yet. So it's waiting for other jobs to run first. And then there's also some problems that might come up because of how Savio is configured. So if you have a condo, then your condo has a specific size. And if all those resources in your condo are already being used, it's going to wait on that condo QoS. And so this could be something you run into that's slowing down your jobs. And in rare cases, you could even have the job make it to the queue, but then there's some problem in the job parameters that mean that no matter how long you wait, it's never going to run. So these are the types of problems you can run into. And we could go over a whole list of like step-by-step how to debug it, but we decided that the best way to do this would be to make a helper script. So I'm here to introduce the script I've been working on. It's a relatively new script, so if you find bugs, please let us know. So this script is loadable as a module. It's called SQ. It's supposed to be an improved version of SQ. And yeah, so let's do a quick demo here. So hopefully this is big enough. So you do module load SQ, and then it will show you your running jobs and your completed jobs. And it will also identify any problems with jobs. So this is just an example of the output. So it shows a table of like the recent jobs for this user, and it highlights the jobs and says a problem it identified with the job that you may want to look into. And usually it will try to recommend a solution. And you can also use that as a replacement for SQ. And there are various flags that are available. You can do -H to see the available flags. So some examples of the errors this SQ script will detect and report to you is perhaps the job is going to intersect with a cluster scheduled downtime. So that means the job would run after the downtime. A possible solution to this would be to reduce the time your job would take to run. So then it could squeeze in right before the downtime. As I mentioned, condo users have a fixed number of nodes in their condo QoS. So you could try changing the QoS if you don't need to use your condo. And other situations might be if your job is requesting a wall clock time. So that's the time the job says it's going to run. That's longer than is allowed for that QoS. It'll just sit in the queue forever. And you might not notice. You might be wondering, hey, it's been in the queue for days and it's not running. So using this script should point that out to you. So here's a quick example. I'm going to pull up my terminal here. This is an example of that condo issue I showed you, I mentioned. So this is a a random user that has jobs that are encountering this problem. So it says this job is waiting until this particular QoS has available resources. So this QoS has a limit of 4 nodes and is currently using all 4 nodes. So each of these jobs is using one of the nodes. So that's for a total of 4 nodes. And this job ID here is requesting 1 node. So obviously it's using 4 of the 4 nodes, so it can't fit in, so it's waiting. And this user has access to Savio low prio. So if they preferred to do that, they could, or they can just wait. It's just letting you know this is a problem that's going to slow down your jobs. It's not necessarily going to make them never run though.
Also, if you also had access to an FCA, you could run under the FCA. There'd be another option there.
Yeah, that's right. It's the SQ script should detect that and list that as one of your options here.
Great.
So you might notice if you just run SQ, there's typically either a node list or a reason. And these reasons are explained by the manual page. And the reasons that we check for with the SQ helper script are explained by the SQ helper script. But if they're not explained by the SQ helper script, you can check man SQ and look through here for the reason list. So these are some of the states of the jobs. These are some of the explanations for the reason codes. So there are 2 very common reasons that you're probably going to encounter all the time. The first one is priority. So this means there are other higher priority jobs being allocated nodes. So your job is currently in the pending state, and it's waiting for the higher priority jobs to get run on the cluster before your job can run. The other state is resources. This means your job is next in priority, so this is pretty good. And it's just waiting to collect the nodes to actually start running. So you're just going to be next. So once you have checked the reasons and you've made sure that your job is, you've used the SQ helper script to make sure that your job is actually going to run, there's no problems, you might wonder, well, when is it going to run? So as Wei mentioned, there's all these calculations to do with priority. And oops, I think I misclicked. And you can use this command to list out some of the priorities. So if we check that, you can look at the Savio 2 partition in this case, and this will show you some of the pending jobs and in their corresponding priority number. So this can give you a sense if your job is stuck because in the pending state because of the priority reason. This can give you a job of like an idea of how many jobs it's waiting for. If your job is in the resources state, and that means it's gathering resources, it's waiting to be the next job to run, you can use sq-start, and this will give an estimated start time. So I emphasize it's an estimated start time. It's not always accurate. And these things are hard to predict because we can't know when exactly the other jobs are going to finish. But this might give you an indication. So finally, you've checked with SQ script that your job is fine, it's going to run, it's just waiting. Now you've got an estimate of when it's going to start. And then the next question is, how can I get my job to start sooner? Because I'm not happy with when it's going to start. So number 1 tip I would say is shorten the expected time limit. So every job has to have a time limit. And the more accurate this time limit is, the better, because then Slurm might be able to fit your shorter job into a gap that it wasn't able to fit in before due to the backfill Wei talked about. So just make sure your time limit is as short as reasonably possible. You wouldn't want to make it too short that it would kill your job in the middle of running, but just make sure it's as accurate as you can make it. You can also, of course, request fewer nodes. So this is obvious because if there's 5 nodes available, but your job's requesting 10, then it will have to wait. But if you request 5, then it could run immediately. You can choose Condo QoS if possible, because this has a higher priority, as Wei mentioned. Condo gets a much higher priority boost. And you can choose a partition with more idle nodes. So you can use this command to figure out which partitions have more idle nodes. So maybe you're deciding between Savio, Savio 2, or Savio 3. We also have this nice dashboard which shows you each partition's current state, number of idle nodes, and the number of idle nodes over time. So if you're wondering, like, should I run on Savio or Savio 2? Maybe right now it's better to run on Savio. One thing to emphasize is just because a node is idle doesn't mean it's available. So you might see 5 idle nodes just because and then you request 5 nodes, it won't run immediately. That might be because it's currently using those 5 nodes to gather for a larger job. But this is a good like heuristic. And then finally, high recent usage decreases your FCA priority. So if you've been submitting a lot of jobs recently, you might have lower priority. So you could switch to a different account, or I guess just wait. So that's all I have here. Yeah, thank you, Chris, and thank you, Wei. If anyone has any questions, I think I'm happy to answer.
Yeah, well, it's now coming up on 5 o'clock, which is when we said we'd finish by. So we finished right on the hour, but we're happy to stick around for as many minutes as needed to answer questions. So please feel free to just interject a question verbally or ask it in the chat. And if it ends up being sort of a more involved question about your own work, we can also split you off into a breakout room with one of us. All right, I'm not hearing any questions, so maybe we'll give it another 10 seconds or so if anybody does want to. Oh, okay. Alvin, I see you have a question. Limit on the number. So are you asking about, is there a limit on the number of low priority jobs that we can submit? It sounds like that's what you're asking. I don't think.
Yeah. So does it count to any allowance? Because it seems like have the lowest priority of the system.
Yeah, it doesn't. As long as you're in a condo, you can submit these low priority jobs, and they're not charged in any way. And I think connected with that, I don't think there's any limit on the number that you can submit.
All right, that's the only question. Thank you very much.
Yeah.
Hey, Chris.
Yes.
Was that a condo user?
I assume so, since he asked about low priority.
Well, the condo user do not have the low priority queue, the QoS, because it's all free for them already.
Wait, what?
They should have low priority. It's
They
for
do?
the case where they're already using all the nodes in their partition or in their condo.
Or if they want to use a partition that they didn't purchase.
Oh, that's fine. Yeah, right.
Yeah, the FCA users don't have access to the low priority queue, I don't believe. So I think that's just for condo users.
Yeah.
All right, anybody else on the call have any questions? Okay, looks like it's mostly BRC folks.
Mostly us.
Yeah, it's just BRC folk now.
Okay, all right, thanks everyone. Talk
Thank
to you
you.
soon.